Students, Mr. Zana again. We're going to be working again today in Unit 3. And in Unit 3, we've been discussing forces. And I know Ms. Knopic just went over the other day Newton's first law of force, the law of inertia. And today we're going to be continuing with Newton's laws. We're going to be covering Newton's second law of force. And we're going to be doing this whole slideshow again as an Edpuzzle. So, chance for Edpuzzle, voices off when it's going on. Raise your hand if you have questions. Watch and have fun. Please stay seated. Watch and be prepared for the exit ticket at the end, and you will be successful in completing your Edpuzzle slides. So like I said, we're still in Unit 3. Unit 3 right here, Newton's laws of motion. So blue arrow's pointing it out. Second page, you can see pointing it out as well. So make sure that you're updating your unit organizer using your vocabulary, your essential vocabulary words, okay? Also making sure that you're putting in definitions such as what Law 2 is, and that will help you to have it ready for a study guide. All right, I'm gonna move my face over. All right, so Q, what? Today we're going to look at Newton's second law of force and how it is calculated. We are going to do an Edpuzzle and a Google form as well. This is going to help us understand how mass and acceleration affect force. Please remember that you have to do your warm-up today as well. And that should probably be done before you do the Edpuzzle. So I have a little video here that's going to explain Newton's second law, force, and the calculation as well. So why don't we go ahead and watch that?
Mass is a measure of an object's ability to resist being accelerated by a force. That means the more massive an object is, the harder it is to make it move if it's at rest, or to stop it if it's moving. The nifty thing about mass is that it doesn't necessarily have to do with size. Think of a big pile of rocks and a big pile of feathers. Both piles are the same size, or volume, but it would take a lot more effort, or force, to move the pile of rocks than it would to move the pile of feathers. The reason? Rocks have more mass than feathers, because they're more dense. To show how it's harder to accelerate something with more mass, picture a student and a teacher, each sitting at rest in a rolling chair, facing each other. Let's also say the teacher is more massive than the student. When they both push off each other, they go rolling backwards. Notice how the student goes back much farther and faster than the teacher. The teacher accelerates less, since she is the more massive of the two objects, and it takes more force to accelerate her than it does the student. All this has to do with Newton's second law of motion, F equals ma. It says for a set acceleration, an object with more mass requires more force to get it moving at that set acceleration. As mass increases, the force required to accelerate or decelerate that mass increases as well. Now, don't you feel massively smarter?
All right, so that is your introduction to Newton's second law, force, and the calculation for that. So, moving on, Newton's second law of motion. Newton's second law states that the total net force acting on an object is equal to the object's mass times its acceleration. So F equals ma, mass times acceleration. An example would be if you had a 2-kilogram ball and you wanted to move it 4 feet per second squared. You would need to multiply the mass times how fast you want it to go to find out how much force you need to move it. All right? So it would be the mass, 2 kilograms, times how fast we want it to go, 4 feet per second, means that we would need 8 newtons of force to move that ball at that speed. All right? So how much force is needed to accelerate a 66 kilogram person at 2 meters per second squared? So again, we're looking at force, F equals ma, mass times acceleration. Okay? So this one it would be 132 newtons. All right. How about another one? Oh, come on. There we go. Kilogram ball at 20 meters per second squared. Well, I'm not going to go through trying to grab the little. Oh, here we go. Let's just do that real quick. Superscript squared. So how much force is needed to move a 10 kilogram ball at 20 meters per second squared? Remember, force equals m times a. So the mass is 10 kilograms, acceleration is the 20 meters per second. So if you said 200 newtons, you would be correct. How about we do one more? How about moving a car that weighs 2,000 kilograms at 2 meters per second squared. 2 meters per second squared. How much force would we need then? All right, that would be 4,000 newtons is what you would need to move that car at 2 meters per second squared. All right, so let's move on to a few more. Oop, that was moved on without me. How about what is the force of a 1,000 kilogram elevator that is falling at 9.8 meters per second squared? So force equals m times a. So mass is 1,000 kilograms, 9.8 meters per second. All right. How about a 50 kilogram skater that is pushed by a friend and accelerates at 5 meters per second? How much force did the friend use to get that 50 kilogram skater moving at 5 meters per second squared? Okay, how about a car with a mass of 300 kilograms is observed to accelerate at a rate of 4 meters per second squared? How much force was used to produce the acceleration? How much force did you need? All right, last one. A cart with a mass of 50 kilograms is pushed to an acceleration of 5 meters per second squared. What force was required to reach that acceleration? 50 kilograms moving at 5 meters per second squared. What's the force needed? Okay, so here's our review. Today we looked at Newton's second law, force, and how it can be calculated using mass and acceleration. We did this wonderful Edpuzzle to practice calculating force. This is going to help us understand how an object's mass contributes to how much force is needed to accelerate it. So your exit ticket is, what do the letters in the following formula represent? So you need to tell me what each one of those 3 letters represent in that formula. So if you can't type directly onto the exit ticket, which I've had a lot of people say, make a copy of it. And then if that still doesn't work, you can go ahead and use a text box. And you can put a text box over it like this. Just put a text box, and you can put your answer right inside the text box. See? Answer. So you can put it right in like that, okay? So to review quickly, force is the second law. Of Newton's second law is force, and it determines how much force is needed to move an object with a certain mass, a certain acceleration. So it's force equals mass times acceleration. It is in our unit organizer, and you need to make sure that you continue to fill out your unit organizer as we go through these sections, okay? As always, if you need any questions, if you have any concerns, you can go ahead and contact myself or Ms. Konopik. Otherwise, we'll see you next class. Thanks.